The topic we are covering is fatty acids. The educational goals are to describe the structure of fatty acids and explain how saturated, monounsaturated, and polyunsaturated fatty acids differ from one another. Fatty acids are carboxylic acids that typically contain between 12 and 20 carbon atoms. The term head is used to represent a polar group and tail is used for a nonpolar hydrocarbon chain. Fatty acids usually have an even number of carbon atoms because they are built from two carbon molecules. Fatty acids differ from one another in the number of carbon atoms they contain and in their number of carbon-carbon double bonds. Stearic acid, it is a fatty acid with 12 to 20 carbons. It's actually 18. And the reason why it is a saturated fat is because in the parent chain it only has single bonds. However, you do not count the double bond at the end because it is not part of the parent chain. This is oleic acid. It is a monounsaturated fat. The reason why it's a monounsaturated fat is it has one double bond in the parent chain. It's just the same as the last one, except for this is the single bond, the double bond inside the parent chain. We do not count this one over here. And again, there's also 18 carbons, but however, it's still different because it's based off the not only the number of carbons, but also the number of double bonds. So this is one, making it monounsaturated.
Okay, you go.
This is linoleic acid. Again, it has 18 carbons, but however, it's a different name because it has two double bonds in the parent chain, as shown here. And once again, we do not count the double bond at the end. It's not part of naming. And this is a polyunsaturated fat because it has more than one double bond in the parent chain. Here are more examples of saturated and unsaturated fatty acids, drawn out in a more clear view. In this slide, we talk about the cis double bonds in unsaturated fatty acids and how they interact less efficiently due to their shape, resulting in weaker London forces, which also results in a lower melting point and boiling point. For saturated fatty acid hydrocarbon tails that interact through relatively strong London forces, they have a high melting point and a high boiling point. Fatty acids become amphipathic when they lose their hydrogen to become carboxylate ions. Saturated fat is fat that consists of triglycerides containing mainly saturated fatty acids and are solid at room temperature. Diets in saturated fat have been thought to be correlated with an increased incidence of arteriosclerosis and coronary heart disease. However, several recent studies seem to suggest that eating diets high in saturated fat did not raise the risk of heart disease. Only trans fats have been scientifically linked. Butter is an excellent example to show saturated fats. In 100 grams of butter packs 52 grams of saturated fat, and in 1 tablespoon there is 7 grams. Another example of saturated fat are dried unsweetened coconuts, which contain 57 grams per 100 gram serving. The sweetened flake variety of coconut contains half as much saturated fat at only 26 grams. The good fats are both polyunsaturated fats and monounsaturated fats, and they are considered good because they help lower your cholesterol levels, ease inflammation, and a number of other beneficial roles. Unsaturated fats are considered healthy or good for you because they contain at least one double bond in the fatty acid chain. Double bonds are a good thing because they help eliminate hydrogen atoms, and both types of unsaturated fats remain liquid at even low temperatures. Foods that contain unsaturated fat are such as olive oil, and in 1 teaspoon only has 12 grams of unsaturated fat and only 2 grams of saturated. Here's a question for you. Why is the melting point of lauric acid lower than that of myristic acid? The reason why is because lauric acid has a shorter hydrocarbon tail than myristic acid, so London force interactions between lauric acid molecules are weaker.